For this portion of the review packet, you're going to have to decode our word equations and put them into their symbols. So let's take a look. I have magnesium reacts with titanium 4 chloride to produce magnesium chloride and titanium. Let's write the balanced equation. First, I'm simply going to write in my symbols. Magnesium, I know that that's Mg, right from my periodic table. When it says reacts with, that means we're going to put a plus sign in between. Next, we have titanium 4 chloride. Titanium being Ti, chloride being chlorine. I know this is an ionic compound because titanium is a metal, so I have to balance my charges. My charge on titanium 4 is plus 4. My charge on chlorine is minus 1, and I get that right from the periodic table. So now I'll take those charges and I'll flip them to give us TiCl4. Next it says to produce. Well, to produce is going to be our arrow. And here we're producing magnesium chloride and titanium. So again, magnesium is our Mg, chlorides are Cl. Again, this is an ionic equation, or rather an ionic compound. Magnesium being the metal, chlorine being the nonmetal. From our periodic table, magnesium has a plus 2 charge. Cl still has a minus 1 charge. So my formula would be MgCl2. That's our magnesium chloride, and then it says and titanium. And being the plus sign, titanium being Ti. Now I have all of my symbols. From here I have to balance my equation. So let's take it one at a time. I have 1 magnesium here and 1 magnesium on this side, so they're balanced and I don't have to do anything. I have 1 titanium on our reactant side and 1 titanium on my product side. So again, they're balanced and I don't have to do anything. Lastly, the chlorines. I have 4 chlorines here, but only 2 here. So I'm going to multiply this entire thing by 2, giving me 4 chlorines on both sides. Putting this coefficient of 2 here didn't just change the number of chlorines, but also changed the number of magnesiums. I now have 2 on this side, meaning I'll have to multiply my reactants by 2 as well. Let's go back and check. I now have 2 magnesiums. I have 1 titanium and 1 titanium. I have 4 chlorides and I have 4 chlorides. This is our balanced chemical equation. The last step here is to determine what type of equation we have. So I take a look. I have 2 reactants, 1, 2. I have 2 products, 1, 2. So it's not a synthesis or decomposition. I have magnesium by itself on this side and titanium by itself on this side. The magnesium comes in and replaces the titanium, bonding with the chlorine. Because we have a replacement and only one thing is being replaced, this is going to be a single replacement. Let's take a look at the second one. Write a balanced chemical equation for the reaction in which carbon reacts with zinc oxide to produce zinc and carbon dioxide. Again, we're going to write that balanced equation. So I have carbon reacting with zinc oxide. Carbon is C. It's going to react with zinc oxide, so react with zinc oxide. Well, I know that this is an ionic compound, so I'm going to have to check my charges. Zinc, if you take a look at our notes, is always going to be a plus 2. Oxide is a minus 2. Because those will balance out to 0, we don't have to put any subscripts in there. Next, I'll put in my arrow, because it's going to react with to produce. So the to produce means the arrow. We're producing zinc by itself and carbon dioxide. Carbon being the C, oxide being the O. How many O's do we have? 2. So I have carbon reacts with zinc oxide to produce zinc and carbon dioxide. Now we have to balance. I have 1 carbon here and 1 carbon here, so we don't have to do anything. I have 1 zinc here and 1 zinc here, so we don't have to do anything. I have 1 oxygen and 2 oxygens. So I'm going to put the multiplier of 2 right up front. Again, I'll check. 1 carbon, we're good. Now I have 2 zincs, so I'll multiply this zinc by 2 to balance that out. I have 2 oxygens, and I have 2 oxygens, so this is balanced. Again, we have to look at what type of equation we have. Carbon comes in, knocks the zinc out in order to bond with the oxygen. Again, this is a single replacement.